Often in geometry, we will see diagrams with intersecting lines. And I'm going to draw two intersecting lines here. And when two lines intersect, they form four adjacent angles. And I'm going to label those angles here 1, 2, 3, and 4. And again, those are labels, those aren't the actual measures of the angles. And there's a lot going on in this diagram, and I want to go over a little vocabulary. First of all, angles 1 and 2, for example, together form what's called a linear pair. They sweep out together a straight line. So I'm going to jot that down. Angles 1 and 2 are a linear pair. And what that means is that the measure of angle 1 plus the measure of angle 2 equals altogether 180 degrees, something you probably already recognized. And we have a term for that. If two angles add up to 180 degrees, like angle 1 and angle 2, then they are called supplementary. So angle 1 and angle 2 are supplementary, and that means that they add up to 180 degrees. And back at this diagram, just like angles 1 and 2 together are a linear pair, so too are angles 2 and 3. They form a linear pair. And 3 and 4 form a linear pair, and 1 and 4 form a linear pair. In addition to linear pairs of angles in this picture, there are also vertical angles. And the first thing I'm going to do here is delete what I've written. So I'm going to get rid of this text here. And I'll keep the diagram. And vertical angles are angles that are across from each other when two lines intersect. So for example, angle 1 and angle 3 are a vertical pair, and angle 2 and angle 4 are a vertical pair. And as you might suspect, vertical angles have the same angle measures. So let me just jot that down. So angle 1 and angle 3 are a vertical pair, and the measure of angle 1 will equal the measure of angle 3. And in similar fashion, we could say the same thing about angles 2 and 4. Now, let's see why vertical pairs are congruent. And I'll do that first with an example and then second with a proof. First, let's do an example. Let's suppose that angle 1 is 70 degrees. So I'll put a 70 degrees here for angle 1. Well, we know that 1 and 2, those two angles, are a linear pair, so angle 2 must be 110 degrees. And we also know that angle 2 and angle 3 are a linear pair, so angle 3 must be 70 degrees. And then you can see that angle 1 must be equal to angle 3. And no matter what value I chose over here for angle 1, the math here would end up with angle 3 equaling angle 1. As long as we keep using numbers to show that angle 1 and angle 3 are congruent, we will never really prove it because we haven't exhausted all the possible number combinations. In order to show that angles 1 and angle 3 are always going to be congruent, we have to write what's called a proof. And here's how we do it. The first thing I'm going to do, though, is to delete some of this text and also delete these values that I had assigned to the angles. And we're going to work just with the angles themselves and not with any measures. So the first thing I'm going to do is note that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And the reason I know that is because angle 1 and angle 2 are a vertical pair. And next, we know that angle 2 and angle 3 add up to 180. So I'm going to write down that. The measure of angle 2 plus the measure of angle 3 equals 180 degrees. And the reason for that is because angles 2 and 3 are a vertical pair. Now what you'll notice at this point is that we have one expression that equals 180 and a second expression that equals 180. So I'm going to substitute this expression in for the 180 that's up here, and I'll get a new equation. And it will be the measure of angle 1 plus the measure of angle 2, which is this piece, is equal to the measure of angle 2 plus the measure of angle 3, which is this piece. And what I've done here is I've substituted this 180 with an equivalent expression. So I've used substitution, and I'll write that over here on the right-hand side. And now when we look at this equation from an algebraic perspective, we can subtract the measure of angle 2 from both sides. And what that leaves us with is the measure of angle 1 equals the measure of angle 3. And what we've done here is we've used the subtraction property of equality. So I'm going to write that here. And what we have shown now is that no matter what values we assign to angles 1 and then hence to 2 and 3, angle 1 and angle 3 will always have the same measures. And that's your first proof.